Join me as I dive into some mind-blowing time travel theories that you probably never knew existed, and see if I can wrap my head around them. When we think about time travel, we often imagine scenarios straight out of science fiction. A DeLorean racing back to the future, a time machine materializing in the Wild West, or a group of friends jumping through a wormhole to save the universe. But time travel theories go far beyond the realm of entertainment, holding significant importance in both scientific and philosophical discussions. In reality, time travel theories have been debated for decades by some of the brightest minds in physics, mathematics, and philosophy. These theories challenge our fundamental understanding of time, space, and causality, leading to a deeper exploration of the intricacies of our universe. From wormholes to black holes, from Einstein's relativity to quantum mechanics, the concepts behind time travel theories have been extensively studied and explored. But despite these efforts, the possibility of time travel remains a fascinating enigma, sparking both curiosity and controversy among scientists and theorists alike. Moving on, let's take a brief look at the history of time travel theories. From ancient Greek philosophers to modern-day physicists, humanity has been grappling with the concept of time travel for centuries. The ancient Greek philosopher Novikov once proposed that any events that occur through time travel have already occurred, and therefore are predetermined. This idea laid the groundwork for further exploration, with later philosophers and scientists building upon these foundational concepts. In the early 20th century, Albert Einstein's theory of relativity revolutionized our understanding of time and space. According to Einstein, time is relative, and its passage can vary depending on the observer's frame of reference. Later, theories like quantum mechanics and general relativity further solidified the idea that time is not absolute, but rather a dimension intertwined with space. In recent years, scientists like Kip Thorne and Stephen Hawking have made significant contributions to the field, proposing new theories and models that attempt to explain the mysteries of time travel. Let's dive into some lesser-known time travel theories and explore each one's unique perspective and implications for our understanding of time. One theory proposes that time travel could be possible through the manipulation of gravitational fields. According to this idea, a massive object such as a black hole could warp the fabric of space-time, creating a wormhole that allows for travel through time. Another theory suggests that time is an emergent property, arising from the collective behavior of particles at the quantum level. This perspective implies that time may not be a fixed one-way dimension, but rather a fluid concept that can be manipulated and altered. The Novikov self-consistency principle proposes that any events that occur through time travel have already occurred, and therefore are predetermined. This idea raises questions about the concept of free will, and whether our actions are truly our own. The bootstrap paradox theorizes that an object or information can be sent back in time, where it is then used to create itself, essentially bootstrapping its own existence. This creates a causality dilemma, as it is unclear what the origin of the object truly is. The grandfather paradox presents a similar conundrum, where a time traveler goes back in time and kills their own grandfather before he has children. This raises the question of whether the time traveler would cease to exist, and if so, who or what would have killed the grandfather. The concept of the multiverse, where every possibility branches off into a separate reality, raises further questions about the nature of time travel. If every possibility exists in a separate reality, then does that mean that time travel is possible, but only within the confines of a specific reality? The theory of eternalism proposes that all moments in time exist simultaneously, and that time travel is simply a matter of moving between these existing moments. This perspective raises questions about the nature of free will and the concept of personal identity. Some theories suggest that time travel could be possible through the use of exotic matter, which has negative energy density. However, the existence of such matter is still purely theoretical and has yet to be observed. The concept of a time loop, where events repeat themselves in a cycle, raises questions about the nature of causality and the direction of time. The predestination hypothesis proposes that every event in history is predetermined, and that any attempt to change the past would be futile. This idea raises questions about the nature of free will and whether our actions are truly our own. The concept of a closed time-like curve, where a time traveler returns to a point before they departed, raises questions about the nature of causality and the direction of time. The theory of quantum entanglement proposes that particles can become connected across vast distances, allowing for instantaneous communication and potentially even teleportation. This raises questions about the nature of space and time. The concept of parallel universes, where every possibility branches off into a separate reality, raises further questions about the nature of time travel. If every possibility exists in a separate reality, then does that mean that time travel is possible but only within the confines of a specific reality? The theory of the cosmic string proposes that topological defects in the fabric of spacetime could be used for time travel. However, the existence of such strings is still purely theoretical and has yet to be observed. Some theories suggest that time travel could be possible through the use of wormholes, which are shortcuts through spacetime. However, the existence of such wormholes is still purely theoretical and has yet to be observed. Despite these fascinating theories, time travel remains a topic of intense debate among scientists, philosophers, and theorists. One of the main challenges posed by time travel is the grandfather paradox, which raises questions about the nature of causality and the direction of time. Another challenge is the issue of free will, which is closely tied to the concept of personal identity. If time travel were possible, would our actions be truly our own, or would they be predetermined by events in the past? Philosophical debates aside, scientists also face significant technical challenges in attempting to make time travel a reality. Developing a means of traversing vast distances in space-time, while also navigating the complexities of quantum mechanics and general relativity, is a daunting task. Despite these challenges, researchers continue to explore new theories and models that attempt to address the difficulties of time travel. One such area of research is in the development of quantum computers, which could potentially be used to simulate and model complex systems, including those related to time travel. Another area of research is in the study of exotic matter, which has negative energy density. Should such matter be discovered, it could potentially be used to create stable wormholes, or to power time travel devices. In the field of astrophysics, scientists are exploring the properties of black holes, which could potentially be used for time travel. However, the technology to harness such energy is still far beyond our current capabilities. As researchers continue to push the boundaries of our understanding, new theories and models are emerging that attempt to address the challenges of time travel. One such theory is the concept of the time crystal, which proposes that time can be manipulated and controlled through the use of exotic matter. Another area of research is in the development of new propulsion technologies, which could potentially be used to power spacecraft capable of time travel. As we continue to explore the mysteries of time travel, we are reminded of the importance of human curiosity and the driving force behind scientific discovery. In conclusion, time travel theories are fascinating, complex, and thought-provoking. They challenge our understanding of time, space, and causality, leading to a deeper exploration of the intricacies of our universe. As we continue to explore and debate these theories, we are reminded of the importance of human curiosity and the driving force behind scientific discovery. So, what do you think about these mind-blowing time travel theories? Do you think time travel is possible, or is it just a fascinating thought experiment? Share your thoughts in the comments below, and be sure to check out some of our other videos on time travel and related topics. Thanks for watching, and until next time, keep exploring.